Right, welcome back grade 9s, and in today's lesson we're going to be working through an example in geometry. Now geometry requires us to have all the right tools in our toolkit before we can even approach something like this, because when we first look at an example like this it might seem quite confusing, but if we know our rules like angles on a straight line add up to 180 degrees, vertically opposite angles are equal in size. Then we move on to things like angles when we have parallel lines. Now that is something exciting, because then we can start using co-interior angles which add up to 180 degrees, corresponding angles which are equal in size, as well as alternate angles which are also equal in size. And what I'm going to try and really get you to understand today is, in a picture like this, we need to try and break it up into smaller pieces so that we can really make sense of it. Now, those are the angles that we deal with when we've got straight lines, when we've got parallel lines, but also sometimes these straight lines make shapes like triangles. And that's what we're going to find today. And something else we need to know about triangles is interior angles of a triangle add up to 180 degrees. And that little special triangle they love to use, the isosceles triangle, that creates two angles at the bottom which are equal in size. And they often rely on our prior knowledge in order to solve something like this. So be sure to make sure that you ensure that you know all of that knowledge. A lot of sures there, so let's be sure. So, in today's lesson I got the question on the board, and it says, given AB, now this symbol over here means parallel, is parallel to CD. As I'm going through this question, I really encourage you to make sure that they've actually labeled that in the picture, because sometimes they actually try and trick you, and they'll give you all the information, but they might not place it on the picture. So when we go straight to the picture, we presume that they've given us all that information without checking, and then we get lost, because all of a sudden it might not make sense to us. So I encourage you to double check. So they've told me that AB is parallel to CD. I must check. AB is parallel to CD. They've given me the symbol. Alright, they've now told me that they are parallel, not just in the question, but also in the image. They then say that CEF. Now CEF means that E is the angle between the two sides of CF, points of CF. So CEF would be CEF is equal to 81. Yes, they have told me that in the drawing, because there I can see it's 81 degrees. And then they say, and EFD, which would be EFD, alright, that's the angle over there, and that is equal to 150. As I can see, it is 150, so they've actually labeled that for me. No tricks here today. And the question then is, write down, giving reasons, the size of all angles P to S in that order. Now, it's very important that if they state they want it from P to S in that order, that we do it in that order. Why are they asking us to do that? Because as I stated in the beginning of the video, often in mathematics, there are different ways for us to work it out. However, for the marker, they want to have one answer. Otherwise, there's a whole long spiel about how we got to our answer, where they want it in a specific way. So, that means we need to deal with it in alphabetical order. So, the angles I'm trying to find are P, Q, R, and S, in that order, P, Q, R, S. So I need to first cast my eyes onto angle P, which is over here, angle P. Now, what are the different ways that I can find angle P? Well, I noticed that this over here is a straight line. CD is a straight line, which is where angle P is. However, it's being cut into two separate angles, but they still lie on the same straight line. Now, because it's around the same vertex, the vertex is the point, alright, where an angle is created. Because it's on the same vertex, it means that these two angles will be supplementary, also known as angles on a straight line. And what is the rules with angles on a straight line? That they add up to 180 degrees. So my statement is that P is going to be equal to 180 minus 150. So what does it equal? 30 degrees. And what will my reason be? Angles, or I could just put a symbol like that, angles on a, and I'm going to put STR, shortened for straight, on a STR line. Because angles on a straight line add up to 180 degrees. So I'm giving them my reason behind my answer. And it's very important that teachers do ask questions like this, because it allows them to see that we understand the concept. There's no point in us just guessing answers or doing it all in our head, because if we make a slight mistake, but we still have the right reason, we'll still get a mark. So this is why it's very, very important for us to take the time to give reasons for our answers. And that's like everything in life. We need to reason things, because if we can reason things, we will make good decisions. Now, moving on to my next letter, Q. Moving on to Q, where is Q? Q is over here. Often in mathematics, when I have my students in our lessons, they won't update the picture, which is very, 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 very important. Because if I update my image, I've now got more to work with, and it'll give me more clues. So P is not just P anymore, P is equal to 30 degrees. So I'm going to slot that in there as 30 degrees. And as you've seen, as soon as I wrote that down, I noticed that angle Q, it's on a straight line, but there's nothing to help me because it doesn't extend, and there's no clue here. But I also noticed that Q happens to be in what shape? It happens to be in a triangle. And what do we know about triangles? The interior angles of a triangle add up to 180 degrees. So, if I have two of the angles, and I'm only looking for the last one, surely that would mean that this angle plus this angle plus this angle equals what? 180. And that actually on its own formulates an equation. So if I said angle Q, I'm just going to do it on the right hand side before I write in my answer over here, angle Q plus 81 plus 30 degrees should equal 180. Now if you know your equations, whatever I'm trying to look for, right, my variable or my unknown should stay on the left hand side and everything else should go over to the other side. Now a few of us have been taught different ways, that if I were to get rid of the 81 on this side, I should subtract 81, but I'm going to fast forward that and just say that if I take 81 across, it becomes a negative, it becomes a minus. But let's first simplify this and say 81 plus 30. So angle Q plus 81 plus 30 gives me what? It'll give me 111 degrees equals 180. Now I can just take one term over, which is a lot easier. So angle Q is equal to 180 degrees minus 111 degrees. Now what is that going to give me? What is that going to give me? Have you got the answer? Angle Q is going to equal what? Take it up to 120, so that's 9 degrees. It's going to be 69 degrees. So I can write here that angle Q is equal to 69 degrees. But what was my reason? My reason were the sum of angles in a, and I can use these symbols in a triangle. Sum of angles in a triangle, because the teacher knows that those will add up to 180 degrees. My next step, ensure that I update my picture. So Q is now no longer an unknown, we've solved for it, it's now 69 degrees. Perfect. We can now move on to the next letter, which is angle R. I'm going to move over to this side and just give us some space here. Let me erase this. So I'm now looking for angle R. Where is angle R? Angle R is at the top. So I look around this area again and I go, well, there aren't any clues inside this triangle. So I'm not going to be able to use the fact that angles inside a triangle add up to 180 degrees. But if I just take a step back, I notice that another one of my clues were that I had a set of parallel lines. So if I have two parallel lines, I can even extend these if I wanted to, right? This acts as a transversal cutting through my parallel lines. And what I know about angles on the inside of two parallel lines and then on the same side of my transversal. So angle R and 69, we know that those two are together, interior, because they're on the inside of my parallel lines. And the rule for that is that co-interior angles add up to 180 degrees. So if I have one of them, that means I can find the other one using another what? An equation. So I can set that equation up. And I can say that angle R plus 69 degrees should equal 180 degrees because co-interior angles add up to 180. And again, I'm going to say angle R is equal to 180. I take the 69 across and it becomes a minus 69. So I'm going to repeat that over here, minus 69 degrees. And I do that. And I've actually done this sum earlier already, so I know that angle R, angle R is going to equal what? 111 degrees. So I write that in there, that angle R is equal to 111 degrees. So now we're winning. I've noticed that this is an isosceles triangle. And we know that an isosceles triangle, I know that the bottom two angles of the equal sides are also equal in size in terms of the angle, right? So the equal sides, the angles at the bottom then, are equal in size. So if this was S, then this also has to be S, doesn't it? Yes, of course it does. Now because S and S are the same, right, that allows me to create the equation. And this might look a little bit complicated to you, but it's exactly what you think and what you do in your tests. Is that S plus S, so angle S plus angle S, plus 111 degrees is equal to 180 degrees. And S and S can be added together because it's the same term. So S and S is going to give me 2S. So 2S, I'll just leave the, or we can use the angle, is equal to, and I'm going to take this across the other side because I'm trying to find the variable, the unknown. It's going to be equal to 180 minus, so 180 degrees minus 111 degrees. And now I'm in a place that I'm quite comfortable. I should simplify this, and 2S is going to be equal to 69 degrees. And it's an odd number, so we know we left with half, because if we divide an odd number by 2, we always left the half. So now say 2S is equal to 69. I only want S. So angle S, I can either do this, put it over 2, or put that side over 2. I know some students still stick to the old school ways, which I don't encourage, but you can also, if this is option 1, option 2 could be angle S is equal to 69 divided by 2, alright? 69 degrees divided by 2, same thing, just spelled differently, potato, potato, however you like to say it. And my answer, angle S, alright, is going to be equal to 60 divided by 2 is 30, 9 divided by 2 is 4.5, so it's going to be 34,5 degrees, and that's angle S, is 34,5 degrees. Now notice that for R, alright, if we go back now, I didn't give my reason. So let's just go back to that. That was just a silly mistake. I simply forgot about it. But angle R, alright, was 111 degrees because of co-interior angles. And if we ever state our reason for being co-interior, alternate, or corresponding, what was the reason why we were allowed to do that? Was because AB was parallel to CD. So in brackets, I must say AB is parallel to CD. I have to state that I saw parallel lines in order for me to use co-interior or corresponding or alternate if I had to use those. Alright, so as you can see, as I said, S was found to be 34.5 degrees, and the reason that we had for that was because it was inside an isosceles triangle. So it's angles inside an isosceles triangle. Isosceles triangles. So we could say angles in a isosceles, you can use that for short, triangle. And those are the reasons as to why we were able to find those angles. So what we've noticed about today is it's very important for us to understand the reasoning behind us finding angles. So what I'm going to do for you is I'm going to give you a little bit of a test. So here it is. We're going to flip it around. And my question to you is, find the size of angle X. Here is my diagram. Make sure to look for the symbols and the clues about why we're able to find that. Formulate an equation and let me know in the comments below what the size of angle X is. But until next time, I need you working hard on these, making sure that we have a toolbox full of all the tools that enable us to find every single angle possible. See you next time. Cheers.